Okay, so I'll give the intuition. First, let's look at a system of two equations. Here, what we do is like Gauss elimination, where we took A11 and used that to sort of cancel off A12. We'll actually try to reduce all the diagonal elements to 1. That is, we want to make A11 be 1, use that 1 to eliminate A12, and then we'll do the same thing with the second column. So normalize one using the pivot A11. So divide 1 by A11, and so you see that this equation will be AX1 plus A12 divided by A11 X2 equals B1 divided by A11. The second equation remains as it is. So A12 X1 plus A22 X2 equals B2. Okay, now use the first equation to eliminate X1 from the second equation. So in this case, if I want to get rid of X1 in the second equation, all I need to do is I'll just take the second equation and subtract it from A21 times, A12 times the first equation. So that would be, let's just call this 1 again. So I've sort of renamed 1. So what I'll do here is my new 2 would be my old 2 minus A12 times 1. This is the old, this is the new. Okay, so I'll keep the first equation as is. And the second equation would be now, since it's A12 minus A12 times the first equation, so there'll be a 0 here, and then I would have A22 minus A12 A11 times A so the ratio will stay, and then we have to multiply that with A12. Is that right? No. Yeah. So just correct this. This is not A12, you should have told me. This is second row, first row. So I was wondering why it was coming up this. This is A21, right? So this should be A21. Yeah, so this is incorrect. This should be A21. Otherwise, you cannot cancel X1. So now we have A21. X2 equals B2 minus B1 divided by A11 times A21. Okay, now you see that you can actually solve for you could solve for x2 right here. Okay, but so this is what we did in Gauss elimination, but that's not what you'll do here. You'll actually do this. You'll use this element to cancel off a12 divided by a11. Okay, so the way you do this is next step would be you normalize. So this is iteration 1. Iteration 2 is, write it down. This is iteration 1. So for the next iteration, normalize second equation using its pivot. So its pivot is what? It's this whole complicated thing that it sits in front of x2, second row, second column. Now that looks a bit complicated, but when you do it numerically, it's going to be just a number. So divide by that using equation by dividing it by a22 minus a12 divided by a11 times a21. Yeah, so the first equation remains as is. And now the new equation down would be x2. There'll be a 1 there because you normalized it. You will have can you scroll up for a second? I should have been writing like this. Is this what you wanted or the previous page? Thanks. Okay. So B2 minus B1 A11 A21 divided by A22 minus A12 A11. It's just a mess, right? It won't be so much of a mess when you do it numerically. Okay, so just to make our life easy, I'm just going to call this B2 star so that we don't have to write so much. But now what you do is, so this is 1, this is 2, use 2 to eliminate x2 from 1. Okay, so if you want to eliminate x2 from 1, what you'll do is you will take 1. The new one would be the old one minus a12 a11 times 2. This will be x1 plus that clearly is 0 because you eliminated that. This will be b1 a11 minus a12 a11 times b2 star, and x2 is b2 star. So if you do it this way, then you'll see that your first equation is now the solution to x1, and the second equation is a solution to x2. You don't have to do any back substitution, and that's how Gauss-Jordan elimination works. Okay, so best way. So in other words, you pretty much get, if you write this is in vector form, matrix form, it's basically an identity. Okay, so what I'll do is I'll solve the same problem I did last time using Gauss-Jordan elimination. And we'll see, of course, if it gives the same answer, and we'll also see if how many steps it takes or how many iterations it takes. Last time we just took 3 iterations. It will take 3 iterations, but you'll see that each iteration you have to do more work because now you have to get rid of everything in the non-diagonal elements. Okay, so let's solve the same problem we did last time using Gauss-Jordan elimination. So 2x1 plus x2 plus x3 equals 7. x1 minus 3x2 plus x3 equals minus 2. 2x1 plus 2x2 minus x3 equals 3. Solve using Gauss-Jordan elimination. We'll use the same technique. We'll create the augmented matrix with 3 rows, 4 columns. 2, 1, 2, 1, minus 3, 2, 1, 1, minus 1, and 7, minus 2, 3. This is A, this is B. Okay, and our goal is that we'll see that we want to reduce this to something which looks like this: 1, 0, 0, 0, 1, 0, 0, 0, 1, C1, C2, C3, where C1, C2, C3 is to be found. But once you reduce it to this form, this is the solution. Solution is x1 will be C1, x2 equals C2, x3 equals C3. Okay, so that's where we're getting to. That's what Gauss-Jordan elimination will do. Okay, let's get started. Okay, if you like, call it iteration 1. Okay. Okay. First, what did we talk about? We talked about taking the first row, first column element. So it's number 2. We observe that 2 is not equal to 1. So we need to normalize that one. So what we'll do is we'll change the first row in the following way. We'll take the first row divided by 2, and that will make that 2 in the first row, first column equal to 1. So that's called normalization. So if we normalize the first equation, we have 1, 0.5, 0.5, 7 divided by 2 is 3.5, then 1 minus 3, 1 minus 2, 2, 2 minus 1, 3. Nothing changes in the second and third equation. Okay, our next step is to eliminate this and this using the first row, first column element. We'll use this, the first row, first column, to eliminate the 1 and 2 below it. So to do that, we see that to eliminate this 1, we would have to do row 2 minus twice row 1. Sorry, row 2 minus row 1, my bad. Just subtracting the first row from the second one will get rid of that. And then if you want to eliminate this 2, the one in row 3, column 1, then it will be row 3 will be row 3 minus 2 times row 1. So there are 2 operations. Let's do them, and you have to carry them out for the entire row. So first row will remain as is. Okay, now let's go to the second row. So 1 minus 1 is 0. Minus 3 minus 0.5 is minus 3.5. 1 minus 0.5 is 0.5. Minus 2 minus 3.5 is minus 5.5. So that completes this operation. The next one is row 3 minus twice row 1. So row 3, which is 2, minus twice 1 is 0. Then 2 minus 2 times 0.5, that's 1. So 2 minus 1 is 1. Next is minus 1 minus 2 times 0.5. So minus 1 minus 1, so it'll be minus 2. There will be 3 minus 2 times 3.5, so 3 minus 7, so it'll be minus 4. Okay, so what we achieved here is we got these to be 0. Okay, let's do iteration 2. Our next goal is to use to normalize this second row, second element. So normalization can be done by taking R2 and dividing it by that particular element. So it'd be minus 3.5. Okay? So don't skip the minus. It's important that you divide by minus 3.5. Okay, so in this bargain, the first row is unaffected. The second row is affected. First element is not, because it's 0. The second row, for second element would be 1. Then we would have minus 0.5 divided by minus 3.5. I actually did that. It's minus 1428. And then minus 5.5 divided by minus 3.5 would be 1.5714. Okay. The third row is unaffected because the operations were only carried on row 2. So 0, 1, minus 2, minus 4. Okay, so we've normalized the second row, second element. Okay, I'm just going to move that to the next page. Okay, now our goal is to take the pivot, which is the element in the first, second row, second column, and eliminate this one, make it 0, eliminate this 0.5, make it 0. So for that, what I'll do is, it's clear that in order to get a 0 here in the first row, second column, it would be R1 equals R1 minus 0.5 row 2. And to get 0 in the first, third row, second column, it would be row 3 equals the old row 3 minus row 2. Okay, now the the good thing about these calculations is that you'll notice is they will keep this, the row which has got 1, 0 like this, unaffected. This row is, so this column is not going to be affected by any of those operations. And the reason is because there is a 0 in the second row. Because of this 0, any operations you do on it is going to leave it unaffected. So in effect, that column is going to just stay as it is. So that you don't even have to think about that, just write it as it is. So 1, 0, 0. Okay, now let's do this for row. Let's do this calculation. Row 1 minus 0.5 row 2. So 0.5 minus 0.5 row 2, which will be 0. Next will be 0.5 minus 0.5 times 0.1428. That actually comes out to be 0.5714. Okay, next is 3.5 minus 0.5 times 1.574. It's 2.7143. And write it down if when you refer this later on. This would be 3.5 minus . Okay, the second row is unaffected, so 1 minus 0.1428, 1.5714. Okay, now we can use this operation. This is kind of straightforward. You just have to take row 3 and subtract from row 2. So row 3, 1 minus 1 is 0, minus 2 minus 0.1428, minus of minus would be positive, so minus 2 plus 1428 would be minus 1.8572, and then minus 4 minus 1.5714 would be minus 5.5714. Okay, so by doing this, what we've achieved is we've got 0, 1, 0 in the second column, and that was what we were after. Okay, now we're not very far from finishing this up. The last iteration is to do the same thing for the third column. For that, the pivot is this thing, minus 1.8572. So we take row 3 and divide it by 1.8572. So that would leave all the other rows unaffected. So I'm just going to copy that down. Last one is divided by 1.8572, so it's 0. Sorry, 1, my bad, 1. And then 5.5714 divided by 1.8572 is 3.001. We'll write it down. This is step to get rid of, it's going to get rid of these two. So what we do here is we do two calculations. So row 1 is row 1 minus 0.5714 row 3, and then row 2 is row 2, so you need to do plus 0.1428 row 3. So if you do that, you'll see that the first 2 columns are unaffected. This will be 0 just by design, and this will be 0 by design. Okay, we need to work with this one, so that one would be let's write it down, 2.7143 minus 0.5714 times 3.001, right? This is 0.5714, and that's 3. And then we have 1.5714 minus, it's plus 0.1428 times row 3, so 3.001, and then 3.001. Yeah, so you can crunch those numbers. I got, just putting those 4 decimal, I got 1.0001, 1.998, 3.001, and this is basically my solution. So the solution is, per this method, the way I did it, x2 is 998. Yeah, which is, for some people that's less accurate, but if you are okay with that accuracy, then with 2 decimal place accuracy, then it's probably good.